Hello children, welcome to the digital class. In your last class, you learnt about basic geometrical ideas. In that, you have lot of concepts. In this session, you are going to learn about one of the concept. Now, look at the screen. Children, what you are observing on the screen? Yes, a house with different mathematical shapes. Now, children, can you tell what are these shapes? Yes, these are closed figures. Now, let us observe the following. Okay, children, what you are observing on the screen? It is a closed figure formed with line segments. How many line segments are there? 3 line segments. Okay, it is also a closed figure formed with 4 line segments that you can see on the screen. It is also a closed figure formed with 5 line segments. And the last one is formed with 6 line segments. Now, she is Adya. She got a doubt and she is asking to herself, what are these closed figures? Children, can you name them? Yes, these are polygons. So, polygons are the closed figures which are formed with only line segments. Now, if you observe the first one, we have 3 line segments. So, a polygon with 3 line segments is called triangle. A polygon with 4 line segments is called quadrilateral. Children, here you can observe this is a polygon with 3 line segments. We are calling it as triangle. This is a polygon with 4 line segments. We are calling it as a quadrilateral. If it is having 5 line segments, then we call pentagon, and if it is having 6 line segments, we call hexagon. Children, observe the screen carefully. This is the polygon with 3 line segments. We are calling it as triangle. This is the polygon with 4 line segments. We are calling quadrilateral. This is the polygon with 5 sides. We are calling pentagon. This is the polygon with 6 line segments. We are calling it as hexagon. Let us know the learning objectives of this session. You will be able to classify the triangles based on the sides and the angles. You can relate the sum of the lengths of 2 sides with the third side in a triangle. You can relate the difference between the lengths of 2 sides with the third side in a triangle. Children, now let us understand what is a triangle. A triangle is a simple closed figure formed by 3 line segments. Children, I have taken first point, second point, third point. I named the first one as A, second one as B, third one as C. Now, what I am doing now? I am joining A point with B point, next B point with C point, next C point with A point. Children, can you tell what it is? Yes, it is a triangle which is a closed figure formed by 3 line segments. Now, these points which we have taken in the triangle are called vertices, and the line segments AB, BC and AC are called sides of the triangle. And children, you observe I am taking here 3 angles, angle A, angle B, angle C. So, from this what we can understand? A triangle is having 3 vertices, that is ABC here, 3 sides, that is AB, BC, AC, and 3 angles, that is angle BAC. Children, try to understand this. BAC means BAC. So, this angle is called angle BAC, or in simplified form we can call it as angle A. Next, angle ABC, ABC. So, this angle is called angle ABC, and what is the last one? That is ACB, ACB. So, we have 3 angles, 3 sides and 3 vertices in a triangle. Now, children, let us understand what are collinear points. If 3 or more points lie on the same straight line, then they are called collinear points. Children, what you are observing on the screen? I have taken 4 points. What are those points? A, B, C and D. Now I have taken a line. Children, what you are observing on the screen? All these 4 points are lying on the line. So can we call these 4 points as collinear points? Yes. So A, B, C and D are collinear points. Okay children, now I will ask you a question. Can we form a triangle with 3 collinear points or not? No, we cannot form a triangle with 3 collinear points. Not only 3 collinear points, you can take any number of collinear points, we cannot form any triangle. So what you can understand here, a triangle cannot be formed with 3 collinear points. Now what you are observing on the screen? A triangle with 3 vertices P, Q and R. So vertices are P, Q, R, sides are P, Q, Q, R and P, R. Okay. Now what you are observing on the screen here? This is the vertex P, this is the side Q, R. Suppose if I ask you a question, what is the side opposite to vertex P? Then what you have to say? You have to say QR. The side opposite to vertex P is QR. Okay children, now what you are observing here? This is the side PQ. For this side, which is the opposite vertex? R. So what you can say here? The vertex opposite to side PQ is R. Okay children, now can you name the vertex opposite to PR side? Yes, it is Q. Can you name the vertex opposite to QR side? Yes, it is P. Now let us understand classification of triangles. We can classify the triangles based on the sides and based on the angles. Based on the sides, triangles are of 3 types. First one, equilateral triangle. Second one, isosceles triangle. Third one, scalene triangle. Now children, let us understand what are these triangles. First, equilateral triangle. A triangle having all the 3 sides of equal length. So if you consider a triangle in which all the 3 sides should have equal length, then we can call the triangle as equilateral triangle. Now what I have done here, I have taken 3 line segments with equal length. Are you able to observe children here? I have taken 3 line segments with equal length, that is 5 centimeters each. Now if I make a triangle with these line segments, I will get an equilateral triangle. Yes. So why I am calling this triangle as equilateral triangle here? Because all the 3 sides are having equal length. So a triangle having all the 3 sides of equal length is called an equilateral triangle. Now let us understand what is an isosceles triangle. A triangle having 2 sides of equal length. Total 3 sides will be there in the triangle. Out of the 3 sides, 2 sides must be equal. Then we call the triangle as isosceles triangle. Children, observe the screen here. I have taken 3 line segments, out of which 2 are equal. 3 line segments, out of which 2 are equal. That is 5 centimeter, 5 centimeter, and the third one is 4 centimeter. Suppose if I make a triangle with this sides, what I am getting here? I am getting an isosceles triangle. So can we call this as an isosceles triangle? Yes. Why? Because 2 sides are equal. See children here, 5 centimeters, 5 centimeters. This is 4 centimeters. So out of 3 sides, 2 sides are equal. So we can call it as isosceles triangle. Now let us understand what is a scalene triangle. A triangle having all the 3 sides of different length. So if you consider a triangle and if all the 3 sides are having different length, then we can call it as a scalene triangle. Children, observe the screen here. This is 3 centimeters line segment, 4 centimeter line segment, 5 centimeter line segment. Now what I am doing here? I am making a triangle with this. Okay, 5 centimeter, 4 centimeter, 3 centimeter. Means no 2 sides in this triangle are equal, or we can say all the 3 sides are of different length. So, can we call it as a scale and triangle? Yes. Now, let us classify triangles based on the angles. We can have three triangles here. First one acute angled triangle, second one right angled triangle, third one obtuse angled triangle. Children, observe the screen here. I am taking an angle here. Observe this, I am taking an angle here. What is this angle equal to? 90 degrees. Now, I am taking another angle. What is this angle equal to? 180 degrees. So, you must know what is 90 degrees and what is 180 degrees to understand acute angle, right angle and obtuse angle. Okay, now acute angle. An angle more than 0 degrees and less than 90 degrees is called an acute angle. Children, can we take 30 degrees as an acute angle? Yes, because it is between 0 and 90. Can we take 80 as an acute angle? Yes, because it is between 0 and 90. Can we take 100 as an acute angle? No. Why? Because it is more than 90. Now, let us understand what is a right angle. An angle equal to 90 degrees. Suppose if you take an angle which is equal to 90 degrees, then we call it as a right angle. Now, let us understand what is obtuse angle. An angle more than 90 degrees and less than 180 degrees is called obtuse angle. Children, try to understand here. If it is between 0 and 90, we call it as acute angle. If it is equal to 90, we call it as right angle. If it is more than 90 and less than 180, we call it as obtuse angle. Can we call 100 as an obtuse angle? Yes. Why? Because it is more than 90 and less than 180. Can we call 150 degrees as an obtuse angle? Yes, because it is more than 90 degrees and less than 180 degrees. Now, let us understand what is an acute angled triangle. A triangle whose all angles are acute, more than 0 degrees and less than 90 degrees. A triangle will have 3 angles. All the 3 angles must be acute. Then that triangle is called acute angled triangle. Children, observe the screen here. I am taking 3 angles in the triangle. What is the first one here? 70 degrees. Second one 45 degrees. Third one 65 degrees. So, can we call it as an acute angle triangle? Yes, because all the 3 angles are less than 90 and more than 0. Now, let us observe another triangle here. So, what are the angles I have taken here? 60 degrees, 60 degrees, 60 degrees. So, can we call it as an acute angle triangle? Yes. Children, we can also call it as an equilateral triangle because all the angles are equal. So, when all the angles are equal, we call it as an equilateral triangle. As all angles are less than 90, we call it as acute angled triangle. Let us understand what is a right angled triangle. A triangle whose any one of the angles is a right angle. Suppose if you consider a triangle, out of the 3 angles, one angle must be 90 degrees. Then we call that triangle as right angled triangle. Children, observe the screen here. I am taking 3 angles, 90 degrees, 60 degrees, 30 degrees. So, out of 3 angles, one is 90 degrees. So, we can call it as right angled triangle. Now, observe another triangle here. 90 degrees, 45 degrees and 45 degrees. Children, can we call it as a right angle triangle? Yes. Why? Because one of the angle is 90 degrees. Now, it is also called isosceles triangle. Why? Because here 2 angles are equal. Sides opposite to these angles also will be equal, means this side will be equal to this side. As 2 sides are equal, we can call it as isosceles triangle. How we are saying that? Because here 2 angles are equal. When 2 angles are equal, the sides opposite to that are also equal. So, it is a right angle triangle and also isosceles. Now, let us understand what is an obtuse angled triangle. A triangle whose any one of the angle is obtuse, means more than 90 degrees and less than 180 degrees. Children, observe the triangle here. I am taking 3 angles. 120 degrees, 30 degrees, 30 degrees. Is this 120 degrees an acute angle? No, because it is more than 90. Is this 120 degrees a right angle? No, it is not equal to 90 degrees. Can we call it as an obtuse angle? Yes. Why? It is more than 90 and less than 180. And here two angles are equal. So, it is also called isosceles triangle. So, it is obtuse angle triangle and also isosceles. Now, observe another triangle here. I am taking three angles here. One is 100, 50, 30. So, we can call it as a obtuse angle triangle. Now, children, observe the screen. I have taken here type of triangle, equilateral, isosceles, scalene. This side acute angled, right angled, obtuse angled. Now, let us understand one by one. Here what I am trying to show here, these sides are equal. So, when I put single line for all the sides, we call them as equal. So, here in this triangle, three sides are equal. So, we are calling it as an equilateral triangle. Okay, children, what you are observing here? These two sides are equal, but this is different. How I am able to show that? Here I am taking single line, here I am taking double line. So, these two sides are equal, but this side is different. So, when two sides are equal, we call it as isosceles triangle. Okay, children, now what you are observing here? This is one line, this is two lines, this is three lines. Means all the three sides are having different length. So, when all the three sides are having different length, we should call it as scalene triangle. So, first one, all sides are equal, so it is equilateral. Two sides are equal, it is isosceles. Three sides are different, so no two sides are equal. So, we call it as scalene triangle. So, acute angle triangle can be equilateral, can be isosceles, can be scalene. Next, okay, children, what you are observing here? These two sides are equal, this side is different. So, we can call it as isosceles. So, it is right angled as well as isosceles. Okay, children, now what you are observing here? This is single line, this is double line, this is triple line. So, all the three sides are different. So, we should call it as scalene. At the same time, one angle is 90 degrees. So, we have to call it as right angle. So, this triangle is right angled as well as scalene triangle. Now, observe the screen, children. What you are observing here? These two sides are equal, this side is different. So, we are calling it as isosceles. These three sides are different. So, we are calling it as scalene. Now, children, here two boxes are empty. Why? An equilateral triangle cannot be right angled. At the same time, a right angle triangle cannot be equilateral. In the same way, an obtuse angle triangle cannot be equilateral, as well as an equilateral triangle cannot be obtuse angled. Okay, children, now observe the screen. We have a triangle with three line segments as sides 4 cm, 6 cm and 5 cm. So, AB equal to 4 cm, BC equal to 6 cm, CA is equal to 5 cm. Children, here I am not taking any bar, which shows that I am taking the length of the line segment. If I take AB over the tail line, we call it as a line segment. If I take only AB, I should call it as length of the line segment. So, what is the length of the line segment AB here? 4 cm. What is the length of the line segment BC? 6 cm. What is the length of the line segment AC? 5 cm. We can call AC or CA. So, these are the three lengths of line segments. We are calling them as sides. Now, observe what I am doing here. I am adding AB with BC. So, AB plus BC means 4 cm plus 6 cm. How much I am getting here? 10 cm. So, what I have done here? I have taken first two sides, I added them, I got the sum as 10 cm. Now, is this 10 greater than 5? Yes. So, AB plus BC is greater than CA. Children, try to understand this. First, I have taken AB, I added with BC, I got it as 10. So, I have taken two line segments, I added the lengths of those line segments and I got the sum as greater than the third side. means sum of two sides is greater than the third side. Now, I am taking next to BC plus CA. BC is 6, CA is 5. So, 6 plus 5 you will get 11 centimeter, which is greater than AB. Next, CA plus AB, 5 plus 4, which is equal to 9 centimeter, which is showing that CA plus AB greater than BC. Children, from this what you can conclude? Sum of the lengths of two sides is always greater than the third side. The sum of the lengths of any two sides of a triangle is greater than the length of the third side. Children, try to understand this. You take any triangle of your choice. You find the sum of two sides. Definitely the sum will be greater than the third side. Now, let us observe whether it is possible to have a triangle with the sides 3 centimeter, 4 centimeter and 5 centimeter or not. Let us take AB as 3 centimeter, BC as 4 centimeter and CA as 5 centimeter. Now, what I am doing here? I am finding the sum AB plus BC 3 centimeter plus 4 centimeter, which is equal to 7 centimeter. Children, is this 7 centimeter greater than 5 centimeter? Yes. Next, BC plus CA 4 centimeter plus 5 centimeter, which is equal to 9 centimeter. Is this greater than AB? Yes. Now, I am finding the third sum here. CA plus AB means 5 plus 3, which is equal to 8 centimeter. Is it greater than 4 centimeter? Yes. So, what you are getting here? Sum of any two sides of a triangle is greater than the third side. Like this, you should check three conditions. You should not check one condition. You have to check all the three conditions. If these three conditions are satisfied, then we say that a triangle can be formed with these measurements. Once again, I am repeating here. You have to check all the three conditions, and all the three conditions must be satisfied, so that we can say this triangle is possible. So, from this what you can understand? Yes, it is possible to have a triangle with the sides 3 centimeter, 4 centimeter and 5 centimeter. Now, let us observe whether it is possible to have a triangle with the sides 4 centimeter, 4 centimeter and 8 centimeter. Now, children, I am taking AB as 4 centimeter, BC as 4 centimeter, CA as 8 centimeter. So, what you can understand here? AB plus BC, first side plus second side measurement 4 centimeter plus 4 centimeter, which is equal to 8 centimeter. Now, is this greater than 8? Can we say that 8 is greater than 8? No, they are equal. So, from this what you can understand? AB plus BC is equal to CA. Next, BC plus CA 4 centimeter plus 8 centimeter, which is equal to 12 centimeter. Here I can say that it is greater than the third side, that is AB. So, BC plus CA greater than AB. Next, CA plus AB, which is equal to 8 plus 4, which is equal to 12 centimeter. So, I can say that CA plus AB is greater than BC. Children, just now I said that all the three conditions must be satisfied, but here what you are observing? AB plus BC is not greater than CA. So, can we have a triangle with these measurements? No. So, what you can say here? As AB plus BC is equal to CA, means sum of two measurements is equal to the third measurement, a triangle cannot be formed. So, what you can say here? No, it is not possible to have a triangle with the sides 4 centimeter, 4 centimeter and 8 centimeter. Now, children, observe the triangle PQR. I am taking here three sides, PQ as 4 centimeter, QR as 6 centimeter, PR as 5 centimeter. So, PQ 4 centimeter, QR 6 centimeter, RP or PR equal to 5 centimeter. Now, what I am doing here? I am finding the subtraction. PQ minus QR means 4 minus 6. Children, what is 4 minus 6? Is it 2? No, it is minus 2. Yes. Now, what you are observing here? When I subtract the lengths of two sides, I am getting the length as less than the third side. Children, observe here. PQ is 4, QR is 6, 4 minus 6 is minus 2. This minus 2 means any negative number is smaller than the positive number. So, what you can say here, minus 2 is less than Rp, means PQ minus QR is less than Rp. QR minus Rp, which is equal to 6 centimeter minus 5 centimeter, which is equal to 1 centimeter. So, I can say that it is also less than, means QR minus Rp is less than PQ. Next, Rp minus PQ, which is equal to 5 centimeter minus 4 centimeter, which is equal to 1 centimeter. Here Rp minus PQ less than QR. Children, in the previous example we are finding the sum of two sides. Here I am finding the difference of two sides. Sum of two sides must be always greater than the third side, and difference of two sides must be always less than the third side. So, children, can we have a triangle with these measurements? Yes, because the difference of any two sides in this triangle is less than the third side. So, the difference between the lengths of any two sides of a triangle is less than the length of the third side. Okay, now let us observe whether it is possible to have a triangle with the sides 3 centimeter, 5 centimeter and 7 centimeter. I am finding the difference here, AB minus BC, which is equal to minus 2. So, minus 2 is less than 7, BC minus CA, which is equal to minus 2, which is less than 3, CA minus AB, which is equal to 4 centimeter, which is less than BC. Children, observe here, AB minus BC less than CA, BC minus CA less than AB, CA minus AB less than BC. So, it is possible to have a triangle with the sides 3 centimeter, 5 centimeter and 7 centimeter. So, three conditions are satisfied, means difference of any two sides in a triangle is less than the length of the third side. Now, let us observe whether it is possible to have a triangle with the sides 3 centimeter, 5 centimeter and 9 centimeter. Let AB equal to 3 centimeter, BC equal to 5 centimeter and CA is equal to 9 centimeter. First I am doing AB minus BC, which is 3 minus 5, which is equal to minus 2, which is less than CA. BC minus CA, 5 centimeter minus 9 centimeter, which is equal to minus 4, it is also less than AB. Next, CA minus AB, 9 centimeter minus 3 centimeter, which is equal to 6 centimeter. Children, observe here, CA minus AB, 9 centimeter minus 3 centimeter, which is equal to 6 centimeter. 6 centimeter is greater than the third side. Actually, the difference between two sides must be less than the third side, but here we are getting greater than. So, what you can say that as CA minus AB greater than BC, that is 6 centimeter greater than 5 centimeter, it is not possible to have a triangle with the sides 3 centimeter, 5 centimeter and 9 centimeter. So, from this example, children, what you can understand, I am finding the difference of two sides for 3 times here. All the 3 conditions must be satisfied. The first 2 conditions are satisfied, but the third condition is not satisfied. So, we can say that it is not possible to have a triangle with the sides 3 centimeter, 5 centimeter and 9 centimeter. Children, try yourself whether is it possible to have a triangle with the following sides 6 centimeter, 6 centimeter and 6 centimeter. Children, here you can either find the sum of two sides for 3 times or difference of the sides. Either you can check with the condition sum of the sides or you can check the condition with the difference of sides. Second one, 4 centimeter, 5 centimeter and 9 centimeter. So, you check whether a triangle is possible with these measurements or not. Okay, children, now you try to answer my question. Can we have a triangle with 2 right angles? Can we have a triangle with 2 obtuse angles? Okay, you try to check this, and this you are going to learn in your next session. Okay, in this session you learnt about the classification of triangles, and you learnt that sum of the lengths of any 2 sides is greater than the third side and difference of any 2 sides is less than the third side. Okay, children, try to solve problems in your textbook. Now, for better understanding of the concepts, solve the worksheets, please visit the official website of SCRT for worksheets. Thank you.